We're going to be practicing going from empirical formula to molecular formula. So this very first problem says the molar mass of the molecular formula of asbestos is 520.8 grams per mole. And my empirical formula is going to be Mg3S2H3O8. Then it says what is the molecular formula. Now the very first thing that I'm going to do is I'm going to find the molar mass of the empirical formula. So the molar mass of Mg3Si2H3O8 Okay, so I have 3 magnesiums, I have 2 silicons, I have 3 hydrogens, and I have 8 oxygens. So then I just need to go to the periodic table and find their masses. So with magnesium, my mass is going to be 24.305. And then for silicon, it's going to be 28.086. For hydrogen, it's going to be 1.08. And for oxygen, it's going to be 15.999. I'm actually not going to do these individually because I don't need to utilize each piece for a percent composition, so I'm just going to go ahead and do it all at once. So 3 times 24.305 plus 2 times 28.086 plus 3 times 1.08 plus 8 times 15.999. Okay, that will give me an empirical mass of 260.103. So this is my empirical formula, mass, molar mass, and then I'm going to go ahead and divide the molecular molar mass by my empirical. So that would be 520.8 divided by 260.103. So 520.8 divided by 260.103, and that is going to equal close enough to 2. This 2 is going to then multiply all of my subscripts for my empirical. So I'm going to take my empirical formula and I'm going to multiply all the subscripts by 2. So that means my final molecular formula would be Mg6 Si4 H6 and O16. My next molecular formula practice problem, I am asked, the molar mass of the molecular formula for lucite is 100.116 grams per mole. The empirical formula is C5H8O2. What is the molecular formula? So I'm going to go ahead and calculate the molar mass for C5H8O2. I have 5 carbons, 8 hydrogens, and 2 oxygens. Carbon's mass from the periodic table is 12.011. Hydrogen's mass is 1.008, and oxygen's is 15.999. I'm just going to go ahead and add those up again. So 5 times 12.011 plus 8 times 1.08 plus 2 times 15.999. That gives me 100.117. So I'm going to go ahead and divide my molar mass by my empirical mass. So that is going to be 100.116 divided by 100.117. that is going to round to 1. This can happen. My molecular formula can be my empirical formula, but that means that my molecular formula is the same as my empirical because I would just multiply these subscripts by 1. So my molecular formula is going to be C5H8O2. My next problem states the molar mass of the molecular formula for sarin is 96.944 grams per mole, and the empirical formula is CHCl. What is the molecular formula? So I need to find the molar mass for the empirical, so for CHCl, I have one of each. Carbon's mass is 12.011, hydrogen is 1.008, chlorine is 35.453. I'm going to add those up. So 12.011 plus 1.08 plus 35.453. That's going to give me the number 48.472. Then all I need to do is divide the molecular formula's mass, 96.944, by the empirical formula's mass, 48.472. And when I do that, I get a nice round 2, which means all I need to do now is multiply all these subscripts by 2, which will make my molecular formula C2H2Cl2. Last problem that I'm going to do states the molar mass of the molecular formula for Orlon is 53.064 grams per mole, and the empirical formula is C3H3N. What is the molecular formula? So I'm going to do the molar mass of C3H3N. I have 3 carbons, I have 3 hydrogens, and I have 1 nitrogen. Carbon's mass is 12.011, hydrogen is 1.08, and nitrogen is 14.007. Okay, that gives me the number 53.064. If I were to divide 53.064, which was my provided mass in my problem, by 53.064, which was the number that I got out of my calculation, since it's the same exact number, I would get 1, which means that the empirical formula is the molecular formula. And so I can establish that my molecular formula is C3H3N. And I'm done.